So good morning. My name is Mark Ryan. I'm the Director of Emerging Technologies for EMEA at Zscaler. And today's session, we're going to talk about Zscaler Private Access and how you can move to a software-defined perimeter to secure your users and secure your applications. As Melanie said, do ask any questions as we go through, and if I can answer them as we go, I will. Otherwise, we'll cover the questions and answers at the end of the session. So, people are moving to cloud for lots of reasons. The concept of cost saving, agility, are moving away from traditional hub and spoke and on-premise solutions. We're taking our applications to the cloud. We're using Box, Office 365, significant uptake in the use of cloud services, AWS, Google, Azure, Rackspace. And we're also seeing a lot more users outside of the traditional hub and spoke network, users working from home, and users working from coffee shops and on the move. And we need to consider, how do we enable those users to continue to access the applications and have the same level of security from those off-site networks as they do when they're on our premises, and the security that we provided on network. So let's take a look at how we would traditionally have built a secure access to internal applications. Users off the network would create a VPN and go through a stack of equipment. We'd have a load balancer to give us resilience. We'd have denial of service protection because we have an exposed IP address to the internet. We'd use firewalls, IPS, IDS to protect that inbound and outbound traffic. We'd have our VPN concentrators, several of them, to be able to provide that inbound remote access. And all of these things to be able to provide a single user or multiple users access to a resource which is internal. And because it's that internal resource, we then have a virtual private network to traverse my internal network and access the applications that they need. As we move to a cloud-enabled world, we use Microsoft Azure, for example. Microsoft would sell us a express route link, or AWS would provide a peered link to give us an extension of our corporate network into their cloud. And therefore, for a user to access a resource that's in Azure, we'd still VPN them into our network, connect across that peered link to access the resource, in this case SAP, and then come back across that link and into that through that VPN connection to allow the user to access that resource. So still using that 20-year-old technology to access cloud-enabled applications. We have to think to ourselves that if the shortest distance between 2 points is a straight line, why would we not enable the user to go direct to this application, but still be able to keep it secure? So the hub and spoke architecture, the concept of providing multiple ingress points into my network. If I've got a globally dispersed network where I have my headquarters in Frankfurt, for example, I've got a gateway in London, and I've got a gateway in Singapore, and bringing those users into my network adds even more complexity. I'm ending up using my internal MPLS network for traffic which is destined for the internet, traffic which is destined for my AWS or my Google Cloud compute platform or Microsoft Azure. It's complex to manage, and the user experience is slow. It's inconsistent. By bringing the users onto my network, I've got to build out my VPN capability and still saturate my network with this traffic, which is ultimately destined for the internet, or destined for my internal network, but I'm bringing them all in through a single gateway. And that's going to cause saturation and pinch points, which add complexity. So, essentially, we're using our legacy technologies, the concept of DMZs, VPNs, and single instances, because that was the technology we built. We've done this for years, but now we need to think about different ways to architect our network, architect our remote access to make it easier and more efficient to access these applications. There's an inherent security problem as well. By providing a VPN, I'm extending my network to these third parties, to these users that are off my network. And so, once the user is connected via a VPN, they have lateral movement in my network. They can move and access every single application that's available. And yes, there are mechanisms to restrict this. There are concepts around putting different users on different VLANs, but again, it adds a level of complexity to the administration tasks for providing access. So this broad attack surface means that there's a greater risk to your internal assets, and by extension, those assets that you've moved to the cloud compute platforms. When you're overexposed, you're vulnerable. Once you've got that VPN open, you're exposed to denial of service attacks to your exposed IP address. People can then spy to your network. Attackers can get into your network. And so taking an approach that enables you to have a kind of a dark net, a network that is not exposed at all to the internet, means that you have a much greater control of the security and the access to the applications that you need to provide people to. So how does Zscaler provide this as part of our cloud security service? So Zscaler's taken the view that you have your inbound and outbound gateways that we've built historically in the past. And you split this out into two gateways, your inbound gateway and your outbound gateway. Your outbound gateway is the things that we built in the past with URL filtering, antivirus, data loss prevention, SSL, and sandbox. And Zscaler provides all of that functionality through our Zscaler Internet Access platform. And that platform enables you to send all of your internet-bound traffic, your outbound traffic, through our cloud service, and where we provide functionality such as cloud sandboxing, SSL interception, next-generation firewalling, URL filtering, of course, and antivirus are standard functions on that, and all of the advanced threat protection. And Zscaler has been doing this for the last 9 years. And that enables you to have a simpler architecture for your outbound internet access from branches, HQs, and also for your roaming users. And that's about accessing these public cloud applications, your Office 365, your browsing to LinkedIn, Facebook, Salesforce. All of those applications are public applications that we give security and granular visibility and control of those users. And then we replace your inbound gateway, all of this functionality that you need for a VPN, your global load balancers, your DDoS protection, IDS, IPS, the actual VPN concentrators, with our Zscaler Private Access service. And that's about providing functionality to control who can access what applications, whether they're in a cloud data center like AWS or Azure, or whether they're in your private data center, no matter where that is around the world. And using Zscaler's global cloud to facilitate the connectivity to these applications. So take a bit of a deeper look as to how that works. So the foundation is around reducing the attack surface on the user, reducing the things that the user can access. The only route for the user is to go via the Zscaler service. So no matter where the user is physically, whether I'm in a branch my corporate headquarters, or I'm a roaming user on the go. If I'm in a coffee shop, the only place that I can go for my access is via Zscaler. And that means that I get a secure browsing experience, meaning I don't get infected with threats, but it also means that for my access to internal resources, Zscaler is the checkpost to say, can I access this resource and can I do it securely? And that means that you have a software-defined perimeter around the device. The device is something that I know and something that I trust, and I understand who the user is and the security of that device to make a policy-based decision on what is this application that the user is accessing. Is it a public application, and therefore we need to send it via the Zscaler Internet Access Service and scan all of the content for threats, or is it a private application that's advertised by Zscaler in your data center and facilitate a secure communication channel in to access that application? And of course, that means accessing all of those applications, whether that are still private applications on your network, Oracle, PeopleSoft, SAP, and also enable you to move those applications from your private data center to the cloud in a secure way that is entirely transparent to the user. So there's no longer a need to secure the network because the network becomes irrelevant. What we're looking at is a secure policy-based access, controlling what the user can access, where the user is able to access that from, and on which devices they're accessing it from. So the approach, the four tenets of this are: the user is not on the corporate network. The application shouldn't require access. We can make a policy-based control, no matter where the user is, without placing the user physically on the network. Meaning, the user is the network is abstracted from the user's access to the application. So we're no longer providing a virtual private network, an extension of your private network to users off your network. We're providing a policy-based access and abstracting the network entirely. The applications are invisible. We never expose those applications to the internet. So applications can't be discovered. The VPN is removed. So the VPN as an ingress to your network is removed as well. And indeed, even the applications are invisible. We only provide access to the relevant applications to the users after we've applied a policy. So whilst you might have 100 applications in your network, we only expose the applications that a user should be able to see to that user. So a user might only be able to see 20 of those applications. The other 80 he has no visibility of. He can't even resolve those applications. So it's providing in some way, a dark net, an ability to restrict applications to specific users. We still use the internet as a connectivity medium, using end-to-end TLS encrypted tunnels. So the user has an encrypted tunnel to the cloud, and there's an encrypted tunnel into the network. And you can use your own TLS security. You can use your own PKI to secure these tunnels. So Zscaler is never in the middle of the data flow. It's encrypted end-to-end through the Zscaler service using your encryption keys. And then it also means that we're segmenting the applications. We don't need to do any kind of network segmentation because we're taking it down to the individual applications. So you're not getting a network-to-network connection. You're getting a granular application-level control as who can access which applications using micro-segmentation of the individual applications. So let's talk about how that actually works. So we have a cloud engine which has all of the policy in there. We understand the attributes about users through an authentication round. We understand which groups users are in, what applications they should be able to access. And that's all based in the Zscaler policy. On the endpoints, the clients, whether it's Windows, Mac, iOS, or Android, the user has the Zscaler app, and the user is federated into the Zscaler app. There's an authentication round that starts to say, authenticate against your Active Directory using SAML authentication. That could be against Ping Federate or Active Directory Federation servers or Okta or OneLogin, all of these SAML identity providers to authenticate the users and fingerprint the device. So we understand everything about the user so that when they go to access an application, we're going to intercept that request. And then the connectors sit in front of your applications. In this case, I have a connector that's running in Azure and is advertising all of the applications that I have there, in this case, SAP. Or I have a connector that sits inside my network and is advertising my SharePoint, my PeopleSoft, my Oracle, and my Exchange. And then the brokers that sit within the Zscaler cloud broker the connection. A user accessing an application through the Zscaler service to identify which connector to use and facilitating that TLS communication end-to-end. And this is for any application, TCP, UDP, client-to-server traffic, all federated and brokered through the Zscaler cloud to provide end-to-end connectivity to those applications. So Zscaler Private Access removes the need for an inbound connection. The connectors are outbound connections to the cloud, meaning you don't need to expose an inbound request. We're not going to accept requests in from the internet to this connector. It's always outbound communication, meaning you get a much better security stack, and therefore all of the functionality around IDS, IPS, DDoS protection is no longer necessary. That's all done, all the inbound connections are done in the Zscaler cloud, and that's what we are securing. So you can absolutely transform your network from a network-based access, where you have to provision DDoS protection, IDS, IPS, multiple ingress points, using your MPLS network to control access and pass data between different data centers, to start to use a policy-based architecture to identify which is the best route to this application. The best route for my roaming user to access the application that I've put in AWS is to connect directly to AWS. Connect to the connector that you place in AWS to access all of those applications securely without advertising those applications to the public internet. So the applications are invisible. They're never exposed to the internet. They're only available to the users that are permissioned within your directory. And for each and every application, they're segmented, meaning that we're doing a policy decision for each request to look up, is this user at this point in time on this device allowed to access this application? And if they are, then and only then do we establish the communication channel for that application traffic to flow. The other part of applying a security policy is understanding what the applications are on the network. And oftentimes that is difficult to say, my users who are using a VPN are accessing these applications. So Zscaler Private Access provides visibility and control and discovery of those internal applications and the usage. So similar to the cloud application security brokerage tools that exist and the Zscaler provides for internet access, we can do that for your internal access. So to give you visibility of those internal applications, where those applications exist, and who is accessing them. So in this example here, we've put in a wildcard discovery. We've said all of Our internal DNS suffix is company.com. In this case, it's safemarch.com, which is our internal testing company. And that allows us to say, okay, users go off and access the applications. And as the users access the applications, we start to identify them. And then we start to name them and understand which servers are advertising those applications. That gives us the ability to then write a security policy around it. In this case, we saw nearly 5,000 applications, over 4,000, but it's close to 5,000 applications. And we can see who the top users are, the number of transactions that they are making to those applications, and graphically represent that in a way that's easy to understand, so you can then write a policy around it. And that policy might be to start restricting this. Why should this user be accessing this application when they're off the network? Or also, this application is being accessed in this way. Perhaps we should think about new ways and innovative ways to deliver that application. Let's move this application to AWS and make it more available to users, because that is the best path, and therefore reduce the complexity and onerous network traffic. So what is Zscaler providing here? So strong authentication. No matter who the user is, they need to authenticate into the service to be able to get access. That's SAML-based authentication. That can include multi-factor authentication on the SAML server. So username, password, SMS message, or Google Authenticator code. Well, that's a function of the identity provider. But then we're also fingerprinting the device to make an understanding of, is this a corporate asset? Is this something that's owned by the company, or is it a third-party device? In which case, then we can apply a device posture around it. So we can say, this user on a corporate device can access the application, but if they're on a third-party device, a bring-your-own device, then perhaps they have a more restrictive policy. All of this is driven through our policy engine, and you can trigger reauthentication policy at different intervals. So I might have a global reauthentication policy to reauthenticate users once a week or once a day, but on a per application basis, I might want to reauthenticate them more specifically on that application access back against your SAML identity provider. We can then start to apply that policy. So the policy either application centric, based on SAML attributes, meaning for an individual application, certain attributes need to be true. So we put it through the authentication round. We might understand the user's groups. We might understand their operating company or the country that they're coming from. All of this returned through the SAML authentication, and then being able to apply a policy based on that. We understand where the user is coming from. So geolocation identifies the user location, and therefore which nodes they should use to connect to, and always finding the most efficient route to connect to those applications, but also being able to apply a policy based on that. On the device, as I said, knowing that the user is on a corporate device or not on a corporate device, looking for SSL certificates, root certificates of your company, registry entries, or certain file checks, knowing these things about the request to then start to apply a policy around that. And then also, individual users, knowing who the user is and which application that he's accessing to write a policy control of that. So in this example, being able to say that users, HVAC consultants, the people who are managing my air conditioning unit, the only thing that they should be able to identify are the air conditioning units themselves. We shouldn't give them access to our network to give them a broad attack surface. Indeed, the only thing they need to access is this one application on HTTP, for example, or SSH. And therefore, they can get onto that, they can do their work, but they can't get to anything else. And we do this by understanding about the device posture. We understand the SAML attributes that identify them as a contractor, and we understand the applications that they need to access. Similarly, the finance users, we identify as being in the finance group, and they should only be able to access the finance applications. Why should finance be able to access the routers, for example? Why should they be able to access the firewalls? So we should restrict the access to that and give them a less broad attack surface to attack. So multiple use cases exist. This isn't just about providing my employees access and replacing my VPN to give me a greater security posture. Yes, it's absolutely there to provide my employees access to individual applications without restricting, without exposing those applications to the internet. But it also allows me to take a cloud-first approach, enables me to move my applications from my data center to the cloud without exposing that move to my users, to make it entirely transparent to my users. So they're never aware of where the application actually exists. Is it in my data center one day and the following day it's in AWS? It should be entirely transparent to the users. Interesting use cases exist with things like mergers and acquisitions and divestitures. You know, as a business, I might acquire another business. And often what happens is those two businesses are using the same IP address space, possibly using the same DNS address space as well. And connecting those two businesses together becomes a challenge for IT, needing to do complex tasks like address translation and DNS propagation to allow one user in one company to access an application in the other company. And all the while, the businesses are saying we need to work closer and get this thing beneficial to both as quickly as possible. So the business efficiency becomes an IT problem. So Zscaler Private Access, because we abstract the network and we abstract the DNS address space, we can actually solve this problem very simply by placing users and connectors in each company and facilitate that traffic access. And then finally, something like partner access. Partners, by extension of our employee access, but should they actually have the same level of access? Probably not. So granting third parties access to our applications and only the applications that they need to do the work that we're trusting them to do, without exposing them to our entire network, because we don't have control. We don't understand what level of antivirus, advanced threat protection they might have on their devices. So why should we trust their devices on our network? So about reducing that attack surface further. So let's compare it. You know, in terms of a VPN, historically how we build this, we build a global load balancer to provide access to my data centers in New York, London, and Singapore. Zscaler provides this as a cloud service. You know, we're available today for our Zscaler Private Access in over 12 locations. Our internet access, we're available in 100 locations. But private access, 12 locations, because typically that is where our applications tend to exist, in more centralized locations. We place in things like external load balancers to load balance the traffic coming into our location. Well, with Zscaler Private Access, we provide best path discovery to access the connectors that we're placing into the network. We'll always find the best path, and you only need to scale the connectors for the number of for the amount of traffic that you're passing. DDoS protection you no longer need to expose that IP address to the internet. And Zscaler Cloud is doing its own DDoS protection. So that's part of our service for the connectivity into our cloud. And therefore, you're eliminating that attack surface and that DDoS threat. And the external firewall and IPS IDS, it's only an outbound connection. The connector is an outbound connection to the Zscaler Cloud. I'm certainly not going to tell you you should just remove firewalls, but the reliance on the firewall IPS disappears. And therefore, compacting that attack surface, compacting your external services architecture to a single firewall is a goal that's achievable. The actual VPN concentrators that you have today provide you a very broad attack surface, meaning they're providing access to the entire network. With Zscaler Private Access and the connectors essentially replace the VPN concentrator and provide you access to individually named applications, reducing that attack surface. And those internal firewalls, the NAC, the internal load balancers, all get replaced by that connector. Because users are never placed on the corporate network. We're given that application segmentation and the load balancing to send traffic across the multiple internal servers that might be servicing an application. So let's kind of walk through exactly how you go about deploying Zscaler Private Access. We deploy the Zscaler app on the endpoints. We deploy the connectors in front of the applications. In this case, I might deploy a connector in my public cloud that's advertising my Jira applications in Azure, and I would deploy a connector in AWS, and all of the applications that are in AWS are serviced by that connector. And I place a connector in my data center that's servicing my facilities and my Oracle application. So one connector servicing multiple applications. I define a policy, and my initial policy might be all users can access all applications, because day one, I don't actually know what those applications are. So I don't use my auto-discovery policy to understand, to work out which those applications are and who's accessing them, to start to build that policy out. And so the first thing that's going to happen is the user's going to try and access the app. I'm going to access jira.company.com. And we know who the user is because we did that authentication round. So we're going to look up that policy and say, is this user even allowed to know that this application exists? If they're not, we just return no DNS response, an NX domain answer. If they are, then we're going to query the connectors, look at the policy to determine they're allowed access to it, and which connector is the best path to service that application. So then we identify that the user is going to access Jira, and Jira is serviced by the connector in my Azure cloud. And we're going to trigger the connector in Azure to establish a connection out to the Zscaler cloud for this specific request. The user is going to have their TLS connection to the Zscaler cloud. We're going to connect those two TLS connections together and then allow the application traffic to flow to allow the access to those applications. And the connector will automatically load balance across those apps that might exist in my data center as well. And of course, I then got visibility. I start to see this user is accessing this application, and this is the way that the path took. And therefore, we've got visibility of the usage, and we've got the ability to detect any anomalies in that usage to start to build our security policy. So, summarizing the benefits, fast response time for the users. We don't need to bring the traffic into your network to go across a peered link into Azure or AWS. Users get the best response time to their application. So no need to hairpin the traffic into my network. The reduced risk, the user's never on the network. They're only allowed to access the applications that we say they can. We're removing that need for to advertise my VPN gateway, which is a DDoS risk. So a lot reduced risk of exposure. The simplification, you're actually getting application segmentation without having to go through implementation of things like network segmentation. You don't need to go off and manage those networks. It's done at an application level. And the ability to move applications to the cloud without any impact to your network. We just stop advertising it in your, from the connector that's in your data center and start advertising it in the connector in AWS. It's that simple, and the application flow just works. And the value, it's not a CapEx expenditure, it's operational expenditure. There's no need to manage boxes. It's virtual machines that you might need to instantiate. And you can start to retire some other kit from this. The global load balancers, the DDoS protection, the VPN concentrators that are difficult to manage and keep updated, and the policy that goes around this. So you get that centralized policy. So, the next steps, we'll certainly engage with you, come in and do a technical deep dive. We can do a proof of concept. We can do some demonstrations. I'm more than happy to take this to the next level. And so I'm going to stop there. I'm going to flick over to the Q&A. If there are any other questions that have arisen from this, please let me know. I have one question here from George. Which application are not supported in Zscaler Private Access? So any application which is TCP, UDP, client to server is supported. SIFS file sharing, SSH, remote desktop, Exchange, HTTP, HTTPS, of course. So any client to server application is supported. Things that require a server to client connection are not supported. So we see things, so in some instances SIP will work, where SIP, for example, takes a connection from the client and goes to a SIP broker to facilitate that communication. Those work. But where you need an inbound SIP connection to the client, that does not work. But typically SIP has moved on, so it'll use brokers to connect. So anything that's using a server to client connection will not work with this because we're not exposing. The follow-up question was around performance. Is it fast? Well, one thing I think you can expect from me, I'm not going to tell you it's slow. So this if we go back a couple of slides, this process here. So number one, in terms of the visibility, you get logging. So you get to see how long it took to establish this, to go through this process of establishing this connection. And this process is typically sub 100 milliseconds for that lookup. But, typically I see it around 10, 20 milliseconds where I am in the UK. And so what is actually happening during this process of querying to the cloud, is this user allowed to access the application, and then establishing the tunnels takes 10 or 20 milliseconds to go through that, and a tunnel is established. So very fast on that. And then the application traffic flows through that tunnel. The only thing the connector is doing is wrapping it in TLS, and the client is unwrapping it from TLS, which is very low overhead as well. So in terms of speed, yes, it is fast.